welcome to episode 4 of Astronomers Without Haircuts, also known as the July 2020 meeting of the Lehigh Valley Amateur Astronomical Society. My name is Rich Hogg. I'm currently the director of the society, which is our elected president-like office, and that will be changing again at the end of this year. And I want to also announce that we are welcoming a few of Professor Judy Parker's students from Muhlenberg College to join us here today. Normally our meetings are open to the public, but we haven't been putting these Zoom meetings out there as a public link. So what we've been doing is instead we're recording this meeting, and I'll edit the recording and put it up on YouTube so the public can check in on us if they want to. But we also have a good partnership with Dr. Parker at Muhlenberg, so we're welcoming a few of her students here so they can get some extra credit for their class or something like that, right? So I'll kick this off by introducing our speaker in just a moment, and we'll have our presentation, and then we'll have a little Q&A session, hopefully, and a brief break, and then we'll come back to order for some club business, such as welcoming any new members. I don't know if we have any that are joining us tonight. A few quick reports from our committees and stuff like that before we move onward. I wanted to say, yeah, normally, under normal circumstances right now, we'd be all queuing up and bugging Bill Dallenberg whether there were any hamburgers ready to eat at our annual picnic. And we would have been worrying about the rain showers, of course, because it was pouring cats and dogs here 5 minutes ago. But unfortunately, with the circumstances what they are, we decided it wasn't practical to have a picnic this year. So instead, we're doing our 4th online meeting. So let me get into this. Our speaker is Tom Field. He's been a contributing editor at Sky and Telescope magazine for 7 years. And he's the author of the, excuse me, author of the RSpec software, which I'm sure he'll tell us a little bit about what that does. It received the Sky and Telescope Hot Product Award in 2011. I'm reading the bio that we have up on our website here, and there's a bunch of advertising lingo that seems like it's intended to convince us that we should have him as a speaker. So yeah, we've done that. We're glad to have Tom Field as a speaker here. But he has been the speaker at NEAF, at the NEAF Imaging Conference, at PATS, at the Winter Star Party, the Advanced Imaging Conference, SCAE, and others. And it says some stuff here about his style. And
you can skip all that.
We'll find out for ourselves.
That's all marketing stuff.
So I'm going to suggest so that we can. I need to make you a co-host so that you can share your materials. So that's done. I'm going to suggest the rest of us use your controls on your Zoom software to turn off your video so that we can concentrate on Tom and his slides. Yeah. And then later on, if we have a question, we can turn our video back on. So
no. Let me countermand that. Leave the video on. I want to see who I'm talking to.
Well, all right, okay.
Thanks, Richard. Otherwise, I'm just talking to a screen.
But hopefully we can manage our screen so that we can see the.
No, you can. It'll work fine. They'll just be down the side.
All right.
And again, if you need to nod off or this isn't your cup of tea, turn your video off. No big deal. But it's fun for me. In fact, I wanted to start. Thank you, Richard, for the introduction. How many of you actually gotten to the NEAF conference over in New Jersey? Just those of you in video, just raise your hands. That's it? Just Bill and Earl and Richard. Okay. We've had a booth there on occasion, so maybe we had a chance to meet. So I'm out in Seattle. It's a cloudy city, which means that I don't do as much observing as many of you may have the opportunity to do. I grew up down in Philadelphia. As I was telling some of the early arrivals, I spent a lot of time over the past couple of decades with some friends up in Saylorsburg. And I love your part of the country, Wind Gap, Saylorsburg, that whole area. So I'm going to talk for about 45 minutes. If you've got questions, you can either write them down at home or chat with them to Richard or me, and we'll look at them after my talk. And I'll be around for as long as you want until you sort of take the hook and drag me off stage. Dr. Parker, tell me a little bit about how far into the term you are and how familiar your students are with things, so I can make sure we don't leave them in the lurch. Here, I'll unmute you. I'm having trouble, Dr. Parker, unmuting you. You'll have to hover over your image and there you go.
I did it. No, we're about halfway through the course, so they've got all the big picture, 6 pieces with the mechanics and the optics, and we're finished planets. Haven't done a lot with stars, but do what you want to do, and they'll pick up, and I can refer back to your rest of the semester. So.
Good. Oh, great. Wonderful. Thanks so much. Okay, so what I'm going to do is share my screen here for a moment. And you should be able to see that prism there now. Is that correct? Thanks, Richard. Let me just get things a little tuned up here. So I'm going to talk a little science and history at first, just to get everybody at the same level. So forgive me if I'm covering things that you're already familiar with. And in the likely event that you might be able to explain them differently and better than me, my double apologies. So let's get things set here. So how is it that we've managed to discover so much about the universe? And really all we've gone is just outside our front door, just within our solar system, really. We can, of course, capture 2D images. This is a great image, by the way. It's the Hubble Deep Field. For those of you who are familiar with it, it's a piece of the sky the size of a tennis ball held at arm's length. There's a lot up there if you look deep enough. And we can get fleeting glimpses of a third dimension, when a eclipse happens, like this one here. And if we wait a while, we can see, look in the upper right-hand corner of that image, you can see the stars going on and off. And these are variable stars. These are RR Lyrae, which are some of the standard candles that we use to talk about distances and determine distances. Now, if we spread the colors out, and actually this is an image from, in my mind, your part of the world, that's up at Lake George, taken several months ago by one of my family members. If we spread the colors out, we get this as if fifth dimension. And I love these colors just right out of the gate. The colors and the gradual transitions from light green to dark green and then into yellow, those kinds of things are really beautiful. This reveals an as-if barcode of the stars that we're observing. And you can see I've identified a couple of the well-known lines, they're called for obvious reasons, that are contained in spectra that we look at. Now, barcodes and spectra in general are used for 50, 60, 70, 80% of the astronomical research that gets done. And they can tell us all sorts of things. First of all, as we saw with those elements, we can see something about their composition. We can also see if the star is moving through Doppler shift. Its RV there stands for radial velocity. Is it coming towards us or away from us? And I'm going to show examples that can be done on an amateur telescope of all these. If the star is spinning, you can measure, you wouldn't think it, how could you measure the spin of the star just by taking an image of its spectrum? But we'll see that, and of course its temperature and where it is in its life cycle on the HR diagram. That'll be a quiz question. Now, by the way, to the doctor students, I won't call on you tonight. I won't quiz you. I won't ask you to say anything. So you can sit back and relax. Don't worry about it. And also we can measure how far away a star is using its spectrum. So for those of you who are amateur imagers, or maybe you want to do some imaging, I thought it would be a good idea to talk about why you might want to do it. And then I'll show you examples of all these. These are points that over the years I've been making in these talks, and I realized for myself I wanted to write them down, and I thought it would be good for you to appreciate them too. So you might want to capture spectra if you remember that thrill of the first image you took of the moon. And maybe you can mute whoever that is, Richard. In fact, I'm going to mute all, and that's nice. It should have muted everybody. Yes. And it didn't mute me. That's nice. It's smart enough to do that. You can hear me now still, Richard, right? Good, thank you. So that first image you took of the moon, if it was like mine, it was blurry, it was overexposed, but it was the most beautiful image you had ever seen. You were showing it to your spouse, your friends, coworkers. You know, it was a blurry white mess, right? Just a brilliant luminous sphere or circle even. But that thrill I found while doing spectroscopy was regenerated, the excitement of something new. And that's one reason you might want to try to capture spectra. You might want to do some new science with your equipment. I know that I've done some imaging, but it was not all that exciting for me. And I wanted to do some science and maybe even contribute to some professional work. You might want to capture star spectra if you want to do something new, but if you're like me, you've got a budget. Last week, somebody used an expression, they were talking about wanting to buy a new piece of equipment, and they said, I'm going to have to consult with my credit card scrutineer. That was this person's way of saying they had to talk to their spouse about spending the money. I've never heard that word scrutineer before. What I'm going to show you tonight is pretty inexpensive. And this is the really cool thing. And I hope that as students, you'll get an opportunity to capture some spectra, perhaps with a remote telescope. When you own the data, it becomes very different than data you're reading in a book or reading in a magazine. It's really surprised me how much more of a commitment and interest I have in understanding what it is I've captured. And the great thing is when you own the data, it doesn't go in one ear and out the other as fast anyway. Things I've read over the years, I've long since forgotten, but when you own the data, that doesn't happen as much. You might want to capture star spectra if you're tired of going out to a dark sky site, because spectroscopy is considerably more immune to light pollution in the city. I'm going to show you some spectra captured here in the backyard about 3 miles from Pike Place Market. And I don't have a PhD in astrophysics. I don't have an undergraduate degree in astrophysics or physics. I'm a knuckle-dragging software guy. And I wanted to know a little bit more about what I was observing, as you will discover tonight is possible. And I'm also not an imager. I don't have the equipment, the patience, the skill, the dark sky sight to do some of those gorgeous images that we see in the magazines and that some of your friends may be capturing. You'll see things that I'm going to shoot here or show you here that were shot on video. And I'm certainly not a do-it-yourselfer. And if you're not, that might be a good reason to try capturing star spectra, because, I mean, you don't have to build something. I break just about every piece of hardware I work with. My favorite keystroke on my computer is Control-Z or Edit Undo. And sometimes I think, wouldn't it be nice if we had an Edit Undo in life? So I'm going to slide my microphone a little bit here, make a little noise. Okay. And next to last, if you want to do some really cool public outreach or mentor students, high school or college students, there's really an opportunity to do that here. And if you want to hang out with a cool crowd, I'm not part of it, but there is a huge community of people doing spectroscopy. So, and they're friendly, they enjoy helping people get started. So I wanted to show you this list just to give you an idea of the themes that are going to be running through my presentation. So we're going to talk a little history here very quickly. Sir Isaac Newton split light using a prism and discovered that white light contained all the colors. And there's another way to split light, and that is you can reflect it off a very finely lined surface like a DVD. And you can even just pass it through a piece of glass that has fine lines on it and get that diffraction. And that's what we do as scientists. So in 1814, you can see there, these dandies, I'm trying to draw a line here. I got to get my hands on the right keyboard keys. This guy Fraunhofer invented spectrometers and observed some stars, but they didn't know what they were looking at yet. It was just colors that differed from star to star. But before we go ahead in time, let's go back in time 500 million years. That thing on the upper left of your screen is a fossil, and notice those fine lines on it. Well, Professor Parker looked at those and said, you know, those sort of look like the lines that we might, you know, reflect off on a DVD and get a rainbow. He said, if that's what that animal had for a shell or a skin, it may have looked like this. And he said, back then, 500 million years ago, in the Cambrian explosion of diversity, it doesn't make any sense for animals to look different unless there's eyes to note those differences and have some of them have an evolutionary value. So he proposed that it was the development of eyes and variegated appearance, including the colors from this kind of shell, that led to this explosion in diversity in life. Okay, back on track now. Most of us are familiar with Bunsen. He invented the Bunsen burner so he could burn samples of just about everything, look at the light through a grating or a prism, and look at the results. And he was a pyromaniac. He burned everything. And the exciting thing was he cataloged it. And so that was one of the stepping stones to our understanding what spectra were and what stars were. Now, Kirchhoff over here on the right, he was a contemporary and friend and co-researcher with Bunsen. And Kirchhoff formulated some ideas. They're called rules. We're not going to get into a lot of depth in them, but one thing about them I'd like to show you. Over on the right there, you can see two spectra. Notice this one has a rainbow with some dark lines in it. But this one in the lower right is all black with some bright lines. So the difference you can see in the labels are absorption and emission spectra. One of the things to notice is the lines are lined up regardless of whether you're looking at an emission or absorption. So what you get depends on things we're not going to discuss tonight, like the temperature of any gas that the spectrum is being created or going through. So we're just going to leave that for now, but you're going to see examples of both those emission and absorption spectra in a few minutes. So in fact, right here are some emission spectra. You can see the different elements have different fingerprints. You can see the hydrogen there has some that are unique. This line in hydrogen doesn't appear in helium. We're going to keep moving fast here, but I want to point out that hydrogen is like a beacon, like a lighthouse that we use when we're studying the stars. And we've even named those lines. We've given the name hydrogen bomber lines, and each line we've given a name from a Greek letter, because we're going to be seeing those lines repeatedly during my talk tonight. This is a great periodic table that the university up there needs, and you can see that it's ours, we sell it. You can see hydrogen, and there are the hydrogen alpha, beta, and gamma lines, just like we saw in the previous image. And over here we can see, for example, that helium has very different lines, right? And if we look over here, here's the lithium in your cell phone battery, and so forth. So these fingerprints are unique for every element in the periodic table as well as molecules in general. So how do we get those spectra? About 100 years ago, a little more, they were prohibited from getting access to telescopes because of their gender. An incredible unkindness and unfairness. The only good thing that came out of that I'm aware of is they were so diligent, so brilliant and creative that as they studied the star spectra that they were allowed to access on these glass plates, they began to notice patterns, and they came up with a way of classifying stars that, again, is still in use today. It was really important for us to be able to sort through the enormous amount of spectra data that was coming from stars in that era and begin to make sense of them. And we have these women to thank for that. Now, on a more recent time scale, Nancy Roman was a PhD astronomer, the first astronomer at NASA. She got her PhD in the late 1940s, and the Hubble Space Telescope was her vision. She made it happen, and she really just drove that project to come to fruition. So another great example of somebody more contemporary. And Elisa here is an exoplanet studier. She's again with NASA, and she has discovered an exoplanet going around a red giant at just the right distance where the water on that planet, if there is water, isn't ice and isn't gas. And so it's a perfect spot where we might find life, which we suspect depends on water. We'll find out whether that's true, hopefully soon, or maybe never. So I wanted to show examples of those great contributors, and there's many more. As I was putting this slide together, And this is a new slide that I put together a few weeks ago. It was really fun to Google women astronomers, and I just got lost reading about all these amazing projects that they're doing. So really briefly, the science, how do we get these emission and absorption lines and spectra? The Bohr model of the atom has electrons spinning around or orbiting in shells, and they jump between shells. And when they jump, they give off energy. And when they jump down, they give off that energy. In that case, it's the hydrogen gamma line. But this particular jumping, you know, I was looking at the slide the other night. Oh, there it is. From level shell 3 to 2, you get lower level energy. It's sort of, and so the light is a different color. So these are the hydrogen alpha, beta, gammas that I mentioned. It's sort of like if you took a tennis ball and dropped it. Once it hits the ground and stopped, it's got less potential energy because it's at a lower level. It's an analogy that explains, or at least helps me remember which way this works, whether dropping generates light or absorbs light. So I love this photo of Einstein with Bohr. I love look at his posture there. I mean, he is like really chilled. Look at that. So some example spectrographs that are in use around the world today. This one on the right is in France, and it discovered the first exoplanet with spectrum. These days, most amateurs certainly capture or detect, typically not discover, but detect exoplanets photometrically. Here's a spectrograph, last image of this sort in Chile, and notice how small the people are compared to it. It's a huge device. Now, one more example, I'd forgotten this one. This is the space shuttle servicing the Hubble spectrograph. And my son says that is not a scientific instrument. He insists that that's a refrigerator and it's filled with beer, and that at night, which of course happens fairly frequently on the space shuttle, or did, they're party animals up there. They turn the video and audio off. I'm pretty sure he's wrong. I'm not sure how to prove that though. So here's an amateur spectroscopy. Next life, I'm going to get into a field that only has one syllable, I think. So this is an amateur setup for doing spectroscopy. It doesn't have to be as complicated as this. I think Dale sometimes regrets that he gave me permission to show this, because I think people come up to him at all sorts of star parties and go, "Hey, I saw your telescope. What a rat's nest." The fun thing about this is look down there at that gas tube. He's using it for some measurements or something. And you can see the little pin sticking out on it. And I picture him at night. I mean, how does he get that thing on? You know, he probably has like 2 alligator clips with high voltage, and he has to clip them on. And, you know, if they touch each other and generate a spark, it ruins his night vision, right? That's a problem. But what I wanted to talk to tonight, to the amateurs who are there, was using this thing. This is a star analyzer grating. It's 1.25 inches, threads onto most or all 1.25 inches threads, and most telescopes. And it splits the light. In fact, you can see a little bit of a spectrum right there on the screen. And actually, this would be fun. I was thinking to try this. I've done this twice before, and it's worked out not terribly. So there's that gas tube. Let's see if we can find, oh, there, see right over my forehead going down through my eye? That's multiple spectra. You can see some green and some red. So this just splits the light just like a prism. All right, let's get this workstation reestablished here. So there's all sorts of ways to use a grating like this. One is just to thread it onto the nose piece or the lens cap threads of a DSLR. Notice there's no tracking here. This is a really inexpensive setup. The grating only costs about $200. But even with that setup, notice we can see, as it turns out, our favorite hydrogen alpha, hydrogen beta, hydrogen gamma on a type A star. So this is not a particularly easy way to get started, because it's a drift spectra, so the stars are moving and the spectra are moving through the eyepiece, but it's doable. But the star analyzer, not only can it be mounted on a DSLR, as I just showed, and in fact, we sell a little adapter that threads onto the nose piece or the lens cap threads, but you can also just mount it typically on the on a cooled fits camera. Down here we have one of these, which is just a ZWO video camera. It can be mono, it can be color, it can be video, it can be a fits camera, and you can even let's see where my mouse went. You can even put it in a filter wheel. So there's lots of ways to mount these things. There are more expensive devices that I'll show you only 1 or 2 examples of tonight. These devices have a small slit, which gives much higher resolution, but it also means that your telescope has to track the stars on a 20 micron slit, 20 millionth of an inch. So they're a lot harder to use, and as you can see, their price point's a lot higher. I bet 1 in 500 amateurs start with these. Almost everybody starts with the grating. And a lot of people use the grating for a few years and go, hey, you know, that was fun. I learned what I wanted to learn. It was real fun. And they never step up. Or they never spend more money. I wouldn't call this stepping up in cost only. Some amateurs do both. They put the star analyzer on a DSLR, and they have a more expensive device down here, piggyback DSLR. Okay, we're now done all that theory, history, equipment. Let's see what we can actually do. So we have a star, we put the light through a grating, and we get the spectrum and the star on our sensor. Here's a great example. This was captured in an 8-inch Newtonian telescope by Torsten Hansen and an imaging source video camera. So each of these is a separate spectrum. He captured it at a different time. And they're in temperature order. So they start at the top up here with the hot type B stars, and then the A, and again, following the acronym OB G, KISS ME, all the way down to the type M stars. By the way, my first NEAF conference was in 2011, and my wife went with me, and she had never really heard me talk about things like this. And when I showed this slide in my booth on the overhead and used the full acronym, Oh Be a Fine Girl, Kiss Me, which is one of the ones, I don't particularly like that anymore. She'd never heard that before, and like her head snapped around. And I mean, she must have thought I'd just go, you know, it was bonkers. You know, what's he, you know, there's a crowd here. What are you saying? You know? So, but down here at the bottom, as I said, are the cool stars. Down here, the type M stars. Look at the differences there. Look at the science that we could already do and that could be done back around the time of the Civil War with gratings. There's differences that allow us to differentiate between different star types. And this is what the computers figured out, the women 100 years ago plus. So just we'll look at one or two examples here, and that's those lines there. Notice that they're not all the same darkness. This one is darker and wider. Now this is the hydrogen beta line, but why would it be darker here and not there and not there? Well, it turns out this line is a result of electrons jumping between shells, as I mentioned. These stars, they're too hot. Some of the electrons just get ionized, get blasted right out of the atom. And these stars, all of these, are too cool. So these don't pump enough electrons up to that shell, and the ones on the very bottom don't pump any, it seems, or not enough to see. One other example here of something cool to look at, and that is these wide bands down here. Now, as I said in that list of 11 top things, I'm not an astrophysicist. So it's not like I know tons of technical details behind everything I'm saying. I've gotten a lot of pleasure learning as I've gone by doing some reading, you know, what this is all about. So I'm going to tell you everything I know about those bands. It's not like, oh, geez, or, you know, there's a whole textbook or chapters written on this. But those bands are from molecules, not just pure elements, but molecules in the shells, in the gas shells of those stars. The stars are cool enough, relatively, that those molecules don't get broken apart by the heat. They're titanium oxide. And now if you learn one more thing about that online after my talk, you'll know more about it than I do. So I want to ask you all, in that crosshairs down here, I'm not going to stop screen sharing for now, but just take a look at it. Can you see that right where those crosshairs are, there's a little bit of dimming in the blue? Dr. Parker, can you see that right in there, a little dimming? How about Skylar? Can you see it, just a head nod? Maybe, sort of, yeah. It's not all that easy to say or see. Say, yeah, I'm witness to that. So, but you know, when you write a scientific paper, it's not enough to say, yeah, we captured the spectrum of Vega, and there was a little dimming in the orange, in the robin egg blue. That's not science. That's art. That's qualitative. So what we do is, in order to actually study this with repeatable and shareable results, we graph the intensity of that black strip. So, I mean, very simply, the star is really bright and narrow, so this is a really high peak and very narrow. Whereas this thing is really wide, so the intensity plot for it is wide, and the really cool thing is we see that dip very clearly. Now there's no question, everybody can see it. And now that we can see that dip, we can do science. How deep is it? How wide is it? How far away is it from others? How does it compare to others? Now we're cooking with gas, hydrogen in this case. So that's the hydrogen beta line. So now how do we get those graphs? To do that, we use software. And just a little bit about my story, and that was I went out in 2009. Here's my grading, and I put my grading on my C8 on my in my backyard here in Seattle, 3 miles from Pike Place Market. And it was a Saturday night, and I came in at midnight. I thought I'd captured some video. My knees were grass stained because Vega's right overhead, so I was down on the ground working. And the next morning, I took some of the software I downloaded and tried to process my spectrum. And this isn't an exaggeration. About 2 hours later, I quit. I gave up. It was like, this isn't fun. Software is crashing. Half of it's in French. There's no manual. It's hard to use. And I gave up. I put this in the drawer. And I told my wife, I don't want to do this anymore. I guess, wasn't worth the time. It's a hobby. It's supposed to be fun. So, but it kept bugging me because I really wanted to do this. So I guess about 2 weeks later at lunch one day, it popped into my head because I'm a software developer. Maybe I should just write some software this weekend that would generate that graph. It'll take me half a day, maybe 2 days. Programmers are awful estimating times. So I did that, and this spectrum is the first one I captured. And now 5,000 or 10,000 hours over or beyond that programming, I'm almost done the software. So let's look. I want to spend about 2 minutes showing you the software. And the reason I want to show it to you is because I think it's helpful for you to see how easy it is to do this kind of thing. So this isn't just a magic graph. So I have over here the image from my camera. Could be a video, mono, fixed camera. There's the star, there's the spectrum. You can even see some gaps maybe on your screen, there and there. So over here is that intensity plot of this region. Whatever region I bracket in is the region that gets plotted here. So we can select the region. And over here are all those dips. See that big dip there? That's that big gap right there. Now I'm going to skip a step calibrating this, which takes about 30 seconds. Maybe we look at it during Q&A if somebody asks. But the main thing I wanted to show you is that, we can see these dips. Now this was done on a webcam in my backyard, 4 frames a second. This is a frame capture, a single frame from that. But I've always been worried, and I was worried then, and I still worry, how am I going to identify those dips? I mean, there's tons of places that those dips could occur. Why there? How do I know what they are? Well, the great thing is Bunsen started out building a reference library of all the elements. So we can just come here and say, hey, show me on this graph where the Balmer lines should be. Where would hydrogen absorption dips be if this star had hydrogen on it? And you look at that, and there's a dip there, and they are all more or less matching. I did things pretty quickly here. There's a dip there, and indeed, that's our hydrogen alpha, our hydrogen beta, our hydrogen gamma. And so these are the result of those hydrogen atoms jumping around. So the other one thing you can do that's sort of cool is you can add some eye candy like that. Now, one final thing to show you on this screen, let's move that out of the way, is I'm going to play you the live video that this was made from. So this is what I saw in real time in my backyard. Notice that there's the star, there's the spectrum. They're moving a little bit, right, because the atmosphere is unstable. There's thermal currents, and the spectrum is changing. But you can still see the lines stay the same. And in fact, one really cool thing is, to finish up, is see how that line, that dip comes and goes by noise, because of the noise. We can tell the software, hey, average, stack the images. Watch how quickly that absorption line comes into being. Because when we stack and average images, we remove the noise. And we've all done that perhaps with imaging. We all have done that perhaps. There's a little bit of a contradiction in that statement. Many of us have done that if we're imagers, stacked images. And I thought it would be fun for you to see that in the spectrum. So I want you just in your mind's eye, just to remember what that looks like, because I'm going to throw it up on the screen This is Vega, and you can see the hydrogen lines. So let's go back to my PowerPoint show. Give me a second. Maybe that was a little longer than 2 minutes, but not much. There we go. So here's a wide field of the sky with the star analyzer grading. There's the star. There's some emission lines, some bright lines. There's another star. There's an absorption line. So you can see, you just bracket them in with the software, which one you want to look at. So when Janet Simpson sent me the spectrum I'm going to show you here, done with just a DSLR and one of those mechanical trackers, I have to confess, I couldn't remember what a Wolf-Rayet star was. You may be in the same shoes right now. I'm being honest here. I wouldn't know. I'd probably read about it a half a dozen times, but how would I remember? Why would I remember? But as I said, once you get your hands on data, even if it's somebody else's, it's much easier to remember, and you have some motivation to go read about it. So Wolf-Rayet stars are, just very briefly, late stage stars. A lot of the outer shell has been dissipated. And so we're no longer seeing hydrogen lines. We're now seeing down towards the center of the star. We're taking a peek inside the normal star. And we're actually seeing absorption lines, or emission lines, excuse me, of carbon, like soot. This is one of the byproducts of the star burning. And we can see it with a backyard spectrometer. It's absolutely amazing. 30 seconds integration time. So if we were to look at an extended object like the Ring Nebula, it would look like that. Now, this is about the only extended object that looks interesting without a slit, because this object really only has two colors. It's got some ionized oxygen and it's got some hydrogen alpha spectra there. And this is an extended object, and if it had lots of other colors and lines, they'd all be on top of each other and it would be smeared. But I'll show you an example of another extended object done with a slit spectrometer, still going to have these oxygen and hydrogen emission lines. Our beloved M42, the Orion Nebula. Same lines right there, right? Hydrogen, oxygen, very narrow lines, but this is with one of those $2,000, $3,000, $4,000, $5,000 and up spectrometers. So, but I wanted you to see what it would look like. Now, I'm going to stop sharing my screen for just a second because I want to, if I can figure out how to do that, I want to ask the group a question here. What happens if I pause share? That's not exactly what I want to do. Let's do the stop share. There, now you can see everybody on video. So for those of you who have seen M42, the Orion Nebula, I'd ask you to just raise your hand, hover your mouse over your video and unmute yourself and share with us what your experience was like. When was it? What did you see? Was it interesting? Anybody? Bueller? Anyone? Anyone? I'm sure there's somebody here who's seen M42.
I've actually taken pictures of it for a thesis for my bachelor's degree in astronomy.
Oh, so you knew what you were looking at. Was that the first time you'd seen it?
Yeah, actually. And I was actually trying to capture, well, I was trying to investigate if the Bowen mechanism existed within the nebula, and using, I think they were called birefringent filters. So I was blocking out certain frequencies that were not in, that were not pertaining to the Bowen mechanism. But
interesting.
It's a very majestic nebula, and one of my favorites.
Yeah, it is. It is majestic.
For obviously emotional attachments.
Yeah, yeah. Understandably, it is majestic. That's a good word. I'm going to start using that. Anybody else can remember the first time they looked at it?
I saw it in my backyard. Yes, saw it in my backyard on a Dobsonian, I think 10 telescope. And you know, Orion is so easy to find. You don't have to be a rocket scientist to do that.
Yeah.
So I just thought it was fascinating.
Great. Good. Well, thanks for sharing that. So there's two good examples. But you were way ahead of me. When I first looked at M42, it was the first time I'd looked through a telescope in Denver. It was at a star party, and there were all these things on the observing field. To my knowledgeless eyes, the observing field had, you know, those cannons at the circus that they shoot people out of? That's what I saw. They were Dobbs, right? But I didn't know any better. But I was queued up And, you know, the amateurs who were running the telescope were talking about it, you know, birthplace of stars, majestic. And when I got to the eyepiece and looked through it, unlike the two of you, I looked and went, so it's a smudge. It's like a cloud. What's the big deal? But, and I would bet some of you have the same experience. Maybe many of you. That's been my experience in talking with amateurs. But all of us still go back and look at M42, even though it's just a stupid smudge. Well, why is that? Well, one of the reasons is, I want to show you a new observing tool I have here. One of the things is that we know how to use averted vision. I want to show you this new invention here. See, I could be looking over to the side here, and now I've got real good averted vision going on. I can get right up to the eyepiece. But I think, all kidding aside, the real reason that we go back and look at M42 is now we understand, and maybe we didn't early on, exactly what we were looking at. Now we understand that it's a stellar nursery, the birthplace of stars, and I would suggest to all of you that as our knowledge grows, I think you'd agree, our enjoyment of visual imaging and visual observing becomes enhanced. And that's what spectroscopy has done for me, is it's given me a little bit more data so that when I do other observing, it's all that much more exciting. So here's another video spectra done of Uranus and Neptune. You can see some big bands done also by Torsten Hansen. And here you can see these deep dips in the spectrum. That's the methane on these planets. Now, 20, 30, 40 years ago, if you told an astronomer that they would be able to use a couple $1,000 piece of equipment in their backyard and observe the atmosphere of planets, they would have given their left leg, right? So, and now it's something that we can all do easily. So here, again, I keep using this word beloved because all the stars are beloved to us, right? So Albireo, A and B, and you can see here that the bluer star has more energy down here in the blue range, the hot blue range, and Albireo A has more energy to the right. Okay, so in 1881, Henry Draper observed a comet. Hey, listen, if Hank can do it, we can do it. Here is a DSLR image. Oh no, it's an 80mm refractor in DSLR. And you can see like this string of jewels here on it. And here you can see the carbon bands, the swan bands. Now this is an extended object, so by all rights, this grading shouldn't have worked if what I was saying was really true. This happens to be a fairly compact comet, which is why we can even observe it even without a slit. Okay, so now anybody who uses a hose clamp as part of their equipment, or not a hose clamp, a C-clamp, is my kind of do-it-yourselfer. And this is the star analyzer grading mounted on the nose piece of that video camera. So what Robin did here, this is one frame down in the corner here, and that's not the tool I wanted to use, it's this one. In this one frame, the meteor traveled that distance. And at this particular moment here, there was an outburst of bolide, and he captured that spectrum and identified those minerals. Pretty cool. Now, this is sort of an esoteric branch of astronomical spectroscopy. It takes a little more work than just looking at stars. I'm not going to talk a lot about the sun because we've had a lot of talk about the sun over the years, except to point out that that yellow line was how we discovered helium. And of course, right before total eclipse, we can just see a little sliver of the sun. So even though normally it's an extended object and we wouldn't be able to use a slitless grating, we can at that moment, which is why right around the time of the Civil War, the reason I hesitated there is when I talk to clubs in the South, I rephrase that and talk about the War of Northern Aggression. And they seem to be more receptive to that. But the fact is, that's a joke I've used for the last 10 years, but I think in this current climate, it's probably outlived its humorousness, if there ever was any. So this may be the last night that I use that joke. So, and there's the helium that we discovered. So you can also use DSLR or small telescopes to observe novae like this. Notice that one has iron, this one doesn't. So you get the idea. So I want to show a couple more, a little bit more complex examples, take a little bit more explaining, but I think you'll appreciate them. We're going to move pretty quickly here. Again, just a really quick reminder that Doppler shift is the change in pitch that sound makes, for example, when it is coming versus going away from us. So like when a train goes through a station, it's high as it's coming towards us, low as it's moving away from us. Well, light does the same thing. So if we're expecting some spectral lines here on a given star, and instead they end up here, what's that tell us? That tells us that it's moving away from us if there's redshift. Or if the lines are shifted the other direction, then we know there's blue shift and it's coming towards us. So, oops, that is not what I wanted to do. I hit the escape key too many times. Let me bring that back up again. One moment as I find that screen. There it is. There. So let's look at an exploding star, a supernova. It happens, and we're going to go real fast through this. This particular type of supernova, which is called a type 1A, when there's two stars and they're circling one another more or less, and one becomes a giant, and some of its gas. I hate this use of this caption that I got off the web. It's not spilling its gas. It's not like it's a flower pot that you're spilling water on. This has gravity, and you know, the gravity is pulling that gas. I mean, water spilling, it's gravity too, but I don't like that word spilling. What happens when you spill gas on something hot? It explodes. That's a type 1A supernova. So there is one in M101, brighter than all the stars in the galaxy. There's a photograph of one, not this one, but a different type 1A. Notice that shell, it's expanding, and I love this image because you really get a sense that it is a shell, right? There's some texture to it. It's different. It's sort of in the middle here. You can see through it as opposed to on the edges. And there's the spectrum that David Strange captured with just a C9 and less than 15 minutes of integration time and a star analyzer grading. There's the spectrum. And as expected, David Strange found a really deep dip right there. Now, when he looked at this in my software, he noted the wavelength down here where that dip was, and it was at 6150 angstroms. So stick with me here, just 3 lines of simple math. Down below, David measured it at 6150. If Bunsen burnt beach sand, he would have measured it as stationary at 6355. So we know there's Doppler shift going on. So I looked up the Doppler shift formula on Wikipedia, because how would I remember it after 40 years? And plugged the numbers in and was able to calculate the speed with which that shell of that supernova was coming towards us. How do we do it? We compared the observed wavelength to the expected wavelength using the Doppler shift formula. Now, I don't know, that could be a quiz on one of your exams coming up. I'm not saying it is, I have no idea. So I don't know how much math you're doing, but that's pretty simple math. So some of you may know this guy, Adam Riess, won the Nobel Prize in 2011 for work that he and his team did just before the turn of the century. He used these type 1A supernovae as standard candles to measure the accelerating cosmological expansion. And here we've observed some of the same stars. I think his equipment probably was a little more high-end than ours, but it's fun to reproduce that kind of research. Here's another example of day by day. You can see that dip. It should be over here. You can see it day by day getting flatter and migrating to the right as that shell gets more and more diffuse and we can see through it to the star. So now what about a black hole at the core of a galaxy? Talk about gravity. A lot of gravity there and a lot of light being given off, not only by the black hole perhaps itself, but more accurately by the stars as they're spiraling into that black hole. So I've never seen 3C273, but David Hayworth has, as well as the spectrum with those 2 little dots that you probably can't see in that postage stamp size screen that you're looking at. There, I've blown it up for you, and you can see there's those 2 dots, and there's the spectrum. Now, this guy, Martin Schmidt, was not much older than our students who are here tonight. He was 25. He was an astrophysicist, and he stared at this and couldn't figure out what those lines were. There's a wonderful transcript of an interview with him, the link to which I can send you, from which I'm describing his experience. He was frustrated. He tried everything. He went away from it. He came back to it. He kept pushing because not only does sticking with it help, But also stepping away from it helps, as a lot of us know, because when we step away, the subconscious sometimes is still grinding. It's why I won't do any hard, real programming after dinner, because then I'm going to dream about it all night, because the subconscious is just working on it. He decided, okay, let me I might as well get rid of the obvious things that this couldn't be, like the hydrogen bomber lines. So there's that screen capture I mentioned in my software I wanted you to remember. And he looked at that and went, well, there we go. It's not hydrogen. There's just no match, right? This emission line, this emission line, there's just nothing matches up here. But then he discovered, oh my goodness, look what he discovered. They do match up with a huge shift. And knowing something about cosmological expansion and the Hubble constant, he was able to figure out how far away this object was. It was 2 billion light years away. And yet it was still bright enough for us to see it here, which meant it was enormously bright. And that was his discovery. He was scared he was wrong because it was such an obvious conclusion once he figured it out. He was afraid he'd publish it. He'd get laughed out of the academy. People would say, you know, of course that's not what it is. And they'd have proofs that would show that he was an idiot. And he called his colleagues in and showed them these results, and they all agreed with him. This was the reasonable explanation. He went home with his buddies. They toasted with wine. His wife said in this interview, he never did that. I knew something was happening. So, amazing discovery that allows even amateurs today to calculate either the Hubble constant or the speed with which that well, either the Hubble constant or the distance this is away from us, using one other known. What amazes me in this, one of our last examples, is how far away and how old this light is, how far away it was when it originated, and the fact that it still has this information in it that allows us to do this measurement. There are other things in the universe that don't age so well. Here's Martin Schmidt today. Now, I do live in a glass house, and I just threw a stone, but not unknowingly. Most of us don't age as well as light. Now, so far, we've been looking at the details of just these hydrogen bomber lines. And those lines are what? About how wide? They're about 50 angstroms wide, right? If we want to drill down and look at the details of one of these, then we have to use a slit spectrometer. And then, if we compare Vega in purple or fuchsia to the moon in blue, we can actually see the radial velocity of this close-in object because we have a lot more resolution. Now, I want to show you one other example. I've got a prop here. This is a rotating star. And let's pretend my fingers are light. It's rotating. So what's happening with this hand? It's coming towards you. So that light is blue shifted. And I'll explain this in a second. And this light, what's happening to it? Well, that hand's moving away from you. So it's red shifted. So we have blue shift and red shift. Now, normally, we'd expect to see this deep dip here on a feature like this. But here's what we see. Vega is a deep dip, but look at Altair. Altair is squashed, it's diffused, it's spread out. Why? Because it's a spinning star and it's spinning so fast that some of the light is shifted into the wings as opposed to staying in the dip. Pretty cool, huh? So how do you get started? Well, you use a diffraction grating like the Star Analyzer, about $200 that I mentioned. Use almost any camera. You may need an adapter or spacer because although it's not critical, it's nice to have the grating approximately the right distance from the sensor in the camera. In many cases, you can just screw it on like that and you're good to go. And you need software. Now, if I was a good salesman and marketer, I would have said this name, RSpec, my software name, countless times during this presentation. I didn't. RSpec stands for real-time spectroscopy. There's other freeware out there that I've used and hasn't been adequate for my needs. So that's how you get started. There's tons of books. As I mentioned earlier, I'm always worried that I'm not going to be able to understand what I'm looking at. Usually, the good news is that there's amateurs out there I can post images to, and they'll explain to me what I'm looking at. But this book, which is that one that you see on the right there, is really a cool book. I'm just looking for an example here. It shows all sorts of spectra and calls out what we're seeing in them, which wouldn't be enough for me because I wouldn't know what they were talking about. But then it's got all this cool prose, and it's written for us. It's not written for undergraduates who are getting a BA in astrophysics or in chemistry. It's not written for professionals. Great book. There on our site are wonderful tutorial videos. There's not a 400-page manual to be reading. On the download site page, you can download the software for free for 30 days without even giving me your email address, and which is a mistake. I need to change that. But as part of that page, there is also sample data and a YouTube video of me teaching spectroscopy in an hour-long workshop in person to the AAVSO a few years ago. It's a great way to learn, and you could do that tomorrow if you wanted to. The AAVSO now has a Spectra database. Stella Kafka is a professional astronomer, and Arnie before her are very committed and making great strides now in terms of getting spectroscopy to be an activity that they're doing. There's opportunities to do professional amateur collaboration. These are almost all amateurs, and they're studying an Epson Aurigae. I don't even know how to say it. Aurigae, I suppose. And this is a star that has, we think it has a dust ring around it, and that dust ring changes as the star changes in orientation and the star changes. So amateurs are helping there. So in the last 2 or 3 centuries, as well as in the last 45 minutes to an hour, we've seen and come a long way. You'll remember Fraunhofer invented this 200 years ago, just yesterday, and look at all we know. And just after 2 centuries. Kirchhoff was a friend of Bunsen's, and they helped us understand what we were seeing. I wanted to show you one more example. We're running a little short on time, so I'm just, instead of asking you to dig up a sky and telescope, or it could be an astronomy magazine, doesn't matter. In the back of these magazines, they always have these galleries with images in them. And these images are gorgeous. I'm glad they're there. There we go. I'm just looking for one. Here is a galaxy, a series of galaxies right there. They talk about it being sort of a rectangular in shape. Bruce Waddington, that's gorgeous. The box, it's called. That's 10 hours of integration time. That's what I was looking for. That wasn't a setup. I could have asked any of you to pull out a magazine. You would have found the same big numbers. As I said earlier, look, I don't have the skill, the patience, the dark sky sight, the equipment, or the interest in doing that kind of imaging. Everything I showed you tonight, with the 2 exceptions that I called out, were done in less than 15 minutes, sometimes at 4 frames a second, which means a 1/4 second per frame. So that's the kind of thing that, if you're interested, you could be doing literally by this time next week. But regardless, I hope, even if you're not interested in doing this, that you've learned something about how we've developed these tools. I apologize for running over. I hope you'll forgive me for that. If you've got questions, I'd love to hear them, and we'll let you all take it from there. By the way, there's my contact information. I hope you'll contact me with questions. So let's unmute everybody, and I'll let you guys, Richard, you might want to drive things if there are questions.
Big round of applause for Tom. Thank you, Tom. That was a great talk. Can you hear me?
Yes.
Oh, good. Yeah, my laptop, which has been running continuously, flawlessly for weeks, had this enormous, scary meltdown right in the middle of the talk. So I'm sure I lost 2 or 3 minutes of your talk, and probably the thing I was recording also, unfortunately. And my microphone also works very well, but sometimes it doesn't come up right away, so I wasn't sure if you could hear me. But thanks, great talk, fascinating stuff, and really very interesting. And I'd like to see if anyone in the audience has any questions for you.
Hi, this is Greg. I was curious how they associate a wavelength with the various emission and absorption lines. Is that just strictly out of like quantum mathematics, or?
Well, they could. These days, they can calculate with various models where they expect the peaks to be, just using the the energy levels of the orbits around the nucleus of the element. But typically, it's done empirically. I mean, you capture an image, much like most science, and then you take a standard, and it could be a gas tube like this, and that has nothing but hydrogen in it. And you superimpose it, and just by trial and error, you find it. Certainly, they didn't know the quantum mechanics. I think, what was it, de Broglie? I haven't thought that name, Dr. Parker. I think he used a simple algebra that was fairly good at calculating what these wavelengths would be, but it gets very complicated as the orbits get more complicated. It's a good question. I meant to mention, very quickly you'll be asking me questions that I can't answer, but I'm broad but not deep in my knowledge. But try me. If you've got any other questions, we'd love to hear them.
Thank you.
You're welcome.
Does your software run on Apple?
It does not, I'm sorry to say. There just hasn't been enough demand. We have a limited light version for Macs for our classroom spectrometer, but it doesn't have all the features that you need to really do astronomy. I'm really sorry to say. Some amateurs, quite a few actually, but not enough to warrant a Mac version itself, have run it on parallels with Windows on their Mac, but of course there's some costs involved with that. It's not quite as friendly as a pure Mac person would like. Sorry. It might be coming, you know. In fact, that whiteboard back there has a list of the features I need to add to get it up to parity on the side there. But that's unerasable on that whiteboard because they've been there for about 2 years.
I had to
What
laugh
else?
when you talked about software estimation.
Yeah. Yeah, we're bad at that.
Yeah, I know.
All right. Well, listen, I'd like to thank you all again. If you have any questions or want to talk anytime, you can always Google my name and RSpec and find me somewhere. Thanks again. And for those of you, and I know many of you do, have been doing outreach over the years, even though you're a little stuck on it now. And for Dr. Parker, who's doing the teaching, I think those are some of the most important things that we can do as amateurs and as citizens, is to reach out and give back. All of us here, by virtue of the fact that we're here, have had amazing opportunities in life, and giving back is part of how we earn that privilege that we had. So keep it up. It's also fun, as those of you who do it, you know. Teaching isn't always fun, as Dr. Parker can say, but a teacher much like her changed my life many, many years ago, and no doubt she and others in this group have changed people's lives. So keep at it, and thank you all again for your time. Have a nice evening.
Thank you, Tom.
Thank you.
Thanks for the applause. See ya.
Wow, that was a whirlwind. Great talk, though. So usually at this time we take a break. I don't know if we need to take a break since we're on Zoom. I'll kind of slow roll it here for a second, but what we're I'll put out some advance warning there. We'll be doing the new member thing here in a minute or two. So Gwen, if you want to start getting ready for that. We did get a chat message from Carl Pico, who had to sign off to take care of some senior parent care, unfortunately. So we can give him credit for being here. I think he's a new member, if I got that correctly. But unfortunately, he didn't get a chance to do the little introductory speech. So Gwen, are you ready to do new member
Can
stuff?
I just interrupt you for a minute before you get started?
Okay, Judy,
Rich?
sure. Oh, yeah, sure.
I just want to say that this is the business meeting, so if the students you don't need to sit through our business meeting, you're welcome to stay. But if you just do, you fulfilled your obligation as soon as you send me the little blip and put it in the Canvas.
Thank you.
Okay, guys, thanks for joining us. Yep. So Gwen, do you want to do the membership portion?
I'm all set. I just had to grab my notes really quick. So, all right, I'm going to start with second readings first. I think they're still present. I'm going to read 2 names, and they're just going to quickly say hi, and that will count as their second reading. So the first one is Mike Boyle.
Hi, everyone.
Hi, Mike. Good to see you.
Thank you.
And the next one is Bill Malcolmus.
I see Bill.
Maybe he took a
I'm
break.
here. Hello, everyone.
Hey, Bill.
Hey, Bill. Good to see you. That will count as your second reading, so you're now a full member of LVAS, so welcome to society.
Thank you all.
All right, so I know we have at least 2 new members that we're hoping to join tonight. To do that, I'm going to read your name. You're going to introduce yourself, tell us how you found out about us, and what your interests are in astronomy. So I'm going to start with Timothy DeMott.
Hi, yeah, you can just use Tim.
Okay.
Yeah, I was introduced actually to astronomy by this organization when I was about, I'm guessing around 7th or 8th grade. A group of men from our church came up to the South Mountain clubhouse up there, and we watched the program with the observatory at that time. I don't know if that's still operational and what have you, but
You mean the planetarium?
Yes, yes.
Okay.
Yeah, I said observatory, but I got that backwards. Okay, yeah, the planetarium.
just double checking.
Yeah, and so that just kind of piqued my interest. I ended up eventually buying a refractory telescope, and oddly enough, one of the first things I did see was the Orion Nebula through it, and it was very amazing. I was able to see the rings of Saturn when they were tilted at the proper axis and what have you. I used to, when I first, we moved shortly after we had that particular presentation to Arkansas. And so getting a clear night usually means in the winter time down there. And the house that we had an attic window. And so to get out of the wind so my telescope wouldn't shake, because it was not a very well put together scope, I went in the attic. And unfortunately, some of the neighbors saw me peering out the window with the telescope. And of course, they thought I was being a voyeur. So that kind of ended that. My parents knew exactly what I was doing because I told them I'm going up in the attic to watch some stars, whatever. But they said, well, it makes the neighbors nervous. but I'm interested in just about everything with regards to our wonderful and amazing universe out there. I found this evening's talk particularly interesting in using the spectrometry to figure out the speed, whether it's coming towards us, going away from us, and what have you. So anything from the craters on the moon to sunspots to nebulae and black holes, of course, which we can't see yet, but we can see through the instruments and what have you. We know they're there. But anyway, that's my interest. And actually, my membership was given to me for Father's Day by my son, Ben, who I suspect is going to be next.
Yes. Thank you so much for sharing your story and telling us what your interests are. And welcome to the society. As you saw, the second reading is really easy. You just have to be at the next meeting and just say hello, and that's all you got to do. So welcome to all of us, and thank you for coming tonight.
Thank you.
All right, and we're gonna go to Ben if he's still online.
Hello, everyone. Thank you for having me. I've always enjoyed looking up at the stars and contemplating the universe, time, and looking up at the night sky. I live right below Pulpit Rock. I can see it from my garden, and I first learned about the organization while on a hike up there, and I would just love to be able to, when there's a clear night, be able to learn how to use those facilities and be able to explore more of about astronomy and the universe we live in. And so I'm curious and want to learn more. So that's what brings me here. So thank you all very much.
Yeah. Well, you definitely came to the right place for sure. So we definitely can help you out with that. So obviously with the health right now, we have to, be a little on the careful side, but once things start opening up, obviously we can get back to doing telescope trainings and such like that. So thank you so much for coming tonight, and welcome to LVS with you and your dad. So we're glad to have you.
Thank you.
All right, Rich, that's all I had. Unless there's anybody else in the audience that was looking to join, that's all I had for membership.
Yeah, I don't think so. Was Carl Pico a new member?
He described himself as a prospective new member, so.
Oh, okay.
He said he wanted to check us out first before committing, so.
All right.
I said that was fine, so.
Yeah. So all right. So we did get that chat from him that he had to sign off. So.
Yeah, I'll probably follow up with him just to see what he thought. So yeah.
Great. So yeah, so Tim and Benjamin and I'm sorry,
Mike and Bill.
Mike and Bill. Yeah, guys, welcome to the club. That's right. Okay, I lost count. I thought I was missing one there. Excellent. Don't mind me. Let's see. I wanted to check in with Blaine to see if we have an update on the book club, but I guess Blaine was not able to make it tonight. So I think Blaine, our education director, somehow in the past couple months got a lot busier than he was planning to, and has been unable to follow up with the scheduling the first discussion group on the book club. So we're all reading. Those of us who have expressed interest in the book club, we're reading The Big Picture by Sean Carroll, and I've read the first 8 chapters, which is the first break point where we said we would discuss it, and then we kind of set it aside till we have a chance to talk about it. So if you're interested in the LVAS book club, there's a chance to get The Big Picture by Sean Carroll and catch up and read the first 8 chapters, and then maybe you can join in when we have our first discussion meeting. Not sure when that's going to be at this point in time. All right, let's see. I wanted to give a quick update on our facility status since we are still under quarantine conditions, more or less here. Social distancing and masks required and stuff like that. Our facilities, excuse me, our facilities are available for use by members, and if you're a full member, you can get keys to the facilities, and you can get some training to use some of the observatories. Now we're requiring some extra precautions. Like, for example, if you want to use one of the club telescopes, we're asking you to get some isopropyl alcohol and take it with you and wipe down the telescope. We actually use it just as a precaution, so that, as we all know, we all might be carrying this darn virus and passing it on to other people without realizing it. So unfortunately, what I've learned is that isopropyl alcohol is hard to find sometimes these days. I had one member calling me and says, I can't find any isopropyl alcohol, and I want to use the telescope at South Mountain. And I told her, maybe go back to the drugstore and try for the little prep wipes that come in little packets. And she was able to get some of those. So the reason we like that is that, it's a good disinfectant for the virus with posing minimal risk for damaging the telescope equipment. So it seems like the best solution. And you can order from Amazon. I just scored 4 quarts of isopropyl alcohol, so I'm stocked. I'm good for a while now. Showed up on my porch a few days ago. I see Bill Dollenberg is online. Bill, do you want to say a few words about status of things at South Mountain?
Everything is good up at South Mountain. Grass is cut now, for those interested. But other than that, everything is going good. If any of the new members or anyone wants to stop in, we're usually there Saturday mornings from 9 to about 12 o'clock. It's best to check with me first and just check online where it says contact us on our website. Look at the South Mountain Maintenance. I'll be listed there.
All right, Bill, thanks. I really appreciate you and Earl and Pete and Mike and Paula for all your efforts on taking care of the grass cutting. And I think you may have heard from Sandra that a couple other people, Eric and Jim Ferrand, are interested in volunteering to help with the grass cutting. Did you get in touch with those people? I'll follow up with you later. But yeah, we have some. It happened on the Pulpit Rock discussion list for some reason, but we have a few other people who are interested in helping out with the grass cutting. So
yeah, there was never a problem. But Eric did stop up today.
Oh, good.
This has been taken care of. We cut it every 7 to 10 days.
Okay, cool.
That's all that's necessary.
Cool. Well, be nice to get more people involved in helping out too if we can. But that's as far as that task is concerned, you're in charge of that. So I just wanted to check if you found out about that. All right, Pulpit Rock. I don't think any of the Pulpit Rock personnel besides me, I guess, are online. Pulpit Rock is also available for use. I know one person who was here today, Jeff, he's still on. I think he inquired about getting a key to Pulpit Rock, and Frank Leiter offered to make arrangements to meet him to get him checked out on the use of the gate in the road and getting in and out so he could get a key. So I don't know if that took place or not, but that is still possible to do that. Pulpit Rock was closed for a while because it's kind of hovers menacingly over the Hamburg Reservoir, and Hamburg for a little while was concerned about their water supply and the personnel that had to take care of that. But they've opened it up again to hikers, and people are using the area, and it's available for us to use. So if you're interested in
Rich, does that mean that the big chain that Ron was talking about is taken down now?
Yeah, I believe so, Andy. I believe the extra chain is gone now. I'm pretty sure. I don't know.
Yeah, it's definitely down because Ron said, I think at the board meeting, that they took it down.
Okay, good. Thanks, Gwen. I'm sure you said something about it, but I didn't remember specifically.
Yeah, I think he was actually there when they were taking it down. That's what I recall anyway.
Oh, okay.
Now, Rich, do we still get a hold of you if we want to get up there, or do we, or is it we bring the alcohol and we're on our own?
No, you're on your own, I think, at this point in time.
Okay.
I forget. Yeah, there's a web page. It's linked from the front page of the website. And if you have trouble finding it, let me know. I mean, I think it's easy enough to find, but excuse me, we did kind of write up some procedures that we want people to follow, and as long as you follow that, we're not requiring everybody to check in all the time.
Thank you.
And hopefully we'll be able to stick with that and maybe loosen it up. But the way things are going, we just have to take it day by day, week by week here, because things are relatively quiet in this corner of the state. In the left lower corner of the state, things are looking a lot worse these days, and the lower right corner of the country, things are looking really bad, and it's just moving around, and we just have to try to respond to things as they develop and try to be sensible about it. Let's see. Our secretary, Dennis, is online. Dennis, you have any comments for the group?
Hi, actually, no, I do not.
All righty, thanks, Dennis. I don't see the assistant director online. I see Francis, our publications director, and Fred, our planetarium director, are online. You have any comments for the group, either of you guys? Fred, you can say something in chat if you want to. So Gwen, you put a question, are we doing the meeting at Pulpit Rock next month for the general meeting? I would guess probably not, but
It's outside though, so why couldn't we do it? If we socially distance, it'd be fine.
Well,
assuming it's not downpouring, obviously.
Yeah. Well,
I know that's what our next meeting is.
We haven't really talked about it, but let me do this. Earl, you're signed up to give a presentation next month. Is that correct? The August meeting?
Yes, but it's not, it's already recorded.
It's already recorded. Wow.
So could you put it on the projector? Like put it up on the projector on the side of the telescope, like we've done in past years?
assuming the, yeah, projector's connect to a computer and that it'll be on a computer and I'll just start it and it'll play.
Okay, so yeah, it should work, assuming we don't get.
In fact, I don't even have to be there.
Be there to answer questions, Earl. I mean,
In fact, I don't have to be there. That's even better.
Well, you got the shortest commute then. You just hit play at home. As long as someone has a copy of it. So.
I guess the things I worry about is if we did get hit with weather, then we could all go back into our cars.
Well, we have the rain date too. I mean,
Yeah.
Saturday is normally the day, and then Sunday is the rain date if it's looking bad.
Yeah, and the other issue, of course, is there's only one bathroom. You know, if 30 or 20 or 30 of us go up there for a meeting, we all have to use the same bathroom. So we're kind of have us.
Well, technically there's two.
There's two. There's the greenhouse.
Well, yeah, nobody wants to use that.
Well, a lot of people do hiking, so I don't think they'd complain, to be honest. But
all right,
as long as you have your own hand sanitizer, you should be fine.
Yeah, I suppose you're right. We'll have to talk about it. We'll have to figure that out.
Okay.
Yeah, the curve is going up again, so I'm.
Well, the death
personally-
curve has gone way down. It's the case count that's gone up, which really isn't the important number. But
I don't want to get into this too much here tonight. Okay, I tell you personally, I would be reluctant to go to a meeting at Pulpit Rock, personally. So, I guess we should maybe do a little bit of canvassing to see how many people would rather do the Pulpit Rock meeting or would rather do the Zoom meeting.
well, those that don't want to go in person could always just, join on Zoom, and we just set up a phone and someone watches through Zoom.
Now, we can't do Zoom with Pulpit Rock because we have no internet.
I have a hotspot I can bring. That's no issue.
Oh, Quinn, you've got an answer for everything.
I'm just trying to get some socialization back. It's been months since we've seen people, quote unquote, like in real life. There's nothing wrong with Zoom, but it's not the same. It really isn't.
Okay.
I also like having choice. People should have choice. If they want to go out, fine. If they don't, then they can do Zoom.
Yeah.
That way we have both options and make the most members happy.
All right, we'll start some kind of discussion about that. Try to get a consensus what we want to do.
Okay.
I know this whole thing has me scared. I'm very timid. I've been practicing social isolation to the extreme and spending an awful lot of time on Zoom. Like I'm on Zoom 4 or 5 days a week. So I know it's different for everybody. And obviously you and I, Gwen, are at opposite ends of the spectrum. So we have to try to find something that works for the majority of us, I suppose. Earl, can you give us a brief update on UACNJ? Do you want to mention anything about that?
Oh, sure. Today was supposed to be their first opening, actual in-person thing, but it was canceled because of the iffy weather, which means that they'll probably go. I think what they're going to do is they'll just go back to do, for today, they'll go back to doing Zoom. It won't be Zoom, it's on Facebook. They'll do an offline thing. But what they were planning on doing was you can go to their website, make a reservation. You can't just show up. You got to make a reservation, but there's no fee or anything like that. There's a limit of, right now, 25 visitors. That doesn't include the people, the volunteers who are working, just 25 visitors. Mask will be required, and, hand sanitizer will be liberally distributed. And what they're going to do is they'll have a presentation outside, and then 1 or 2 telescopes will be open, but you won't, the image will be projected on the observatory next door. So no one will actually go into the observatories except for the volunteers. And so then you just sort of walk around to the different observatories, see what they're looking at, as you would normally. And then they also have the opportunity, there's a couple of people who have the ability to use their own telescopes at home and send images into, live images into there. And they were thinking that maybe they would use, after the presentation is done, they could use that projector and that screen for some remote stuff. So they might have as many as 3 telescopes open. And then, of course, that's all, since it's all outside, that's all weather dependent. So they generally, the rules they've decided is that by 3 o'clock, they'll decide whether it's going to, weather is going to be okay or not. And that's it. Like I said, today was going to be the first day, but they canceled it because of the iffy weather.
Iffy. It was raining like just before the meeting here. It was
it did rain.
Downpour.
It did rain here too, but now it's all sunny out. So
yeah, rained pretty much all day yesterday, but we know what that was. All righty. Thank you, Earl. Does anyone else have anything you want to bring before the group before we adjourn for the evening? Floor is open.
Hey, Rich, I'd just like to say I agree with Gwen on trying to have a meeting up at Pulpit Rock for August. It'd be nice to get outside and get to see everybody again.
Okay, Sam. I hear you. Hey, there's Jim Farrand. I didn't know you were with us, Jim. How you doing?
Yeah. Oh, I'm sorry. Yeah, I've been here in the background. Yeah, I just want to support that motion too. Even though I'm one of the old codgers in the dangerous category, I'm ready. So I would like to see that meeting too, like you said, properly run, and so.
All right. Well, we'll start.
Yeah, I also wanted to mention, I'm immunocompromised. A lot of people don't know that. Yeah, I'm young, but I have health issues that make me very susceptible to illnesses, and I likely had the virus in March. So I know there's risks, but I think everybody should have the right to make the decision if they want to go.
Sure.
I want to say would like to have a meeting as well up there on Pulpit Rock, partly because I live much closer.
All right. Anybody else want to chime in on that one? We'll see what we can do. We'll see what we can put together. I'm not sure I'll join you, but we all have our own response to this. And
well, you can watch on Zoom. We'll get it set up so you can watch on Zoom, Rich.
Yeah, you should plan to test out your hotspot up there, make sure it works.
I'm sure it will. It's Verizon. It works everywhere.
Yeah, Verizon is a little spotty up there. Sometimes it doesn't come in as good as you think. You only get like 1 bar or 0 bars in some spots. So
I'll test it out. I'll let you know.
Okay.
Yeah, you have to get toward the edge, but if you're close enough, you can probably pick it up. The edge of the mountain. You can't do it right at the thing.
Oh, you go over towards the lookout, you mean?
Not that far. Just a bit over toward the edge, because I've been up there with my cell phone. Of course, I have AT&T, and that might be tougher.
Yeah.
Yeah, I'll have to test it. It's a Verizon hotspot.
Okay.
I'll work on that in the meantime.
It'd be valuable to know if it works up there too. It'd just be valuable in general.
Yeah, because internet up there would be nice. So.
Yeah, for sure. Yep.
Hey, Rich.
Yeah.
Were you going to talk about the 40-inch at all?
Well, I've been writing the column every month, except for last month I didn't do it because I got off on other. I'm planning to do some work on it over the next week or two, and write some more on the next column. I don't really have too much to say. The big thing, we're doing some research now, and I haven't got an update from Frank lately, but we're doing some research and trying to decide exactly how we're going to do the refinishing of all the metal components. We're looking into powder coating, and I know that Bill Malcolmus, our new member, was in touch with Frank with a recommendation on powder coater. We have the webpage project I did where a bunch of people put in suggestions about color schemes that we haven't gone back and really tried to summarize those yet, but that's one of the things I want to do for the newsletter. Yeah, we've kind of got a little bit distracted on a few things, but that's what we're working towards right now. So I would say check on, actually, let's see, the newsletter just came out is July. It doesn't have a column. Look for the August newsletter for an update on everything that's happening with the 40-inch. At this point, yeah, we're hoping to get all our act together to resume the build full steam next year, and maybe get a working telescope by the end of the year next year, if we can get all the ducks in a row. Yeah, but we've kind of let the pandemic throw us off the rails a little bit more than we already were. So, all right. Anybody else? Floor is open. Okay, well then I guess we'll call it an early evening tonight, so we can all go have those hamburgers that we're cooking ourselves, since we couldn't have our picnic this month, unfortunately. Thank you, everybody. We'll see you all next week, one way or the other. We'll either see you Zooming from Pulpit Rock or Zooming from wherever. We'll figure that out, and I want to thank everybody for expressing your opinions on that. I'm glad to try to work with what the group is most interested in doing, and do the best we can. So thanks, everybody. Great meeting. We'll catch you next month.
Was.
Thank you, Rich.
All right. Thanks, Rich.
Bye, everybody.
Good talk.
Stay safe, everybody. Stay safe.